Hi, and welcome to the Chapter 2 Test Review Part 1. So your job is to copy down these 13 questions, not only for your notes for a grade for this week, but also because these are almost exactly the same questions you're going to have on your test, and this is going to be how you do it. So let's get started. Number 1 that you're going to copy down is solving for x, and the equation is 4, parentheses, 3x minus 4 equals negative 88. So, of course, with a question similar to this one, what you're going to want to do is distribute. So when you distribute, that means that you're going to take the number that's on the outside of the parentheses and multiply it by everything on the inside. So 4 times 3x is going to be 12x, and 4 times negative 4 is negative 16, and bring the rest down. After you distribute, you're going to want to move your constant to the right side so that you can get the variable all alone. So we're going to add 16 to both sides. Those cancel, 12x comes down, equals, and this is going to be negative 72. Our last step is going to be divide, and we're going to divide by 12 because that's what is attached to x. And negative 72 divided by 12 is negative 6. All done. Number 2 is also a solve for x. And in number 2, there are variables on both sides. It's 5x plus 6 equals 7x minus 12. And our goal is to get the x's on one side of the equation and your constants on the other side. But since we've done inequalities, it's best to keep your x's on the left. It's just good practice. So if that's the case, what we're going to do is we're going to take our 7x and we're going to subtract it over. Remember, it's got to go under its like term with the 5x. 5x minus 7x gives us negative 2x. And we're going to bring down the plus 6. And we're going to bring down the negative 12. After you get the x's on the left, we want to move the constants to the right. So we're going to subtract 6 on both sides. Be careful of your combining of your sign numbers. Bring down your negative 2x. And negative 12 minus 6 is negative 18. So you can use a calculator on these. So please make sure you do so that you don't make silly errors. We're going to divide both sides by negative 2. And a negative divided by a negative is a positive. So this is 18 divided by 2, which is going to be a positive 9. Okay? So watch your signs. Number 3 is solve for x, but we have a fraction. You knew we had to put some fractions in here. We worked on them for a long time this unit. Okay. So what I'm going to ask you to do first is I'm going to ask you to turn all terms into a fraction. Okay, and that means, and I'm going to go pink on this so that you can see it quite literally, that I'm going to put this over 1 and this over 1 so that all of the terms have a fraction. Now, if you're wondering why I didn't put a 1 under the x, it's because this x is attached to the 3 over 2. So this is literally just a long fraction bar. So this is all over 2. All right, so even though it's next to it, because it's a multiply, the x belongs on the top and it stays with the 3. After we get all of our terms into fraction form by making ones, then what you're going to do next is you're going to create a common denominator. So this is a 2, this is a 1, and this is a 1. So we need to multiply each of these by 2. And remember that whatever we do to the bottom, we're going to do to the top. So I need to multiply this by 2 and this by 2. That keeps its equivalence. And this turns this into the same denominator. And I got to multiply this by 2 and this by 2. And that maintains equivalence and turns this into a 2 into the denominator. So what I have is a denominator of 2 for the 3x, a denominator of 2 for the 15, and a denominator of 2 for the negative 48. And that means that we are ready to write our equation. So after we get all of the denominators to be the same, then you solve the numerator. But don't forget that you need to multiply these out. So my new equation is going to say 3x minus 15 times 2 is 30. And negative 48 times 2 is negative 96. Okay, so I'm not keeping the 15 and the 48. I still have to multiply these two together. And I have to multiply these two together. And that's what makes the fractions now equivalent so that we can only solve the numerator. Now that we solve the top, we're going to do that by moving the constant. So I'm going to add 30 to each side. I'm going to cancel that. 3x comes down. And this becomes negative 66. And then we're going to divide. So we divide by 3. And x equals negative 22. So again, the thing that people get tripped up on as far as fractions go is turning all terms into a fraction. That's what we did with pink. We did that here by, oh, that's not very bright. Hold on a minute. Let's make that real light. There we go. We did that by putting ones underneath. And then when you create a common denominator, that means that we turn all the bottoms and tops differently to create a common denominator. Then you can cross it out and solve the top. Okay. Once you solve the top, don't forget that you're multiplying these two together to give us our new numbers, and then we just go ahead and solve. All right, we're on number 4. It says solve for y and graph the solution on the number line. Here's our number 4. 10y plus 2 is greater than 6y plus 12. So our goal is to keep the variables on the left. So to do that, I need to subtract 6y over across the symbol to the other side. That cancels. 10y minus 6y gives us 4y, and we're just going to bring the rest down. After you keep your y on the left, which we did, now we're going to move the constant. So we're going to subtract 2 on both sides. Notice the symbol hasn't changed at all. And then we are going to divide by 4. And when we divide by 4, it's positive. When we divide by a positive, our symbol stays exactly the same. I think this is 2.5. So now that we've solved it, we have to graph it because it's an inequality. So we're going to draw a number line. 2.5 is our main concern. It is not equal to, there's no line under it, so it's going to be an open circle. And this says y is greater, and greater is everything on the number line to the right. So that's what your graph looks like. So get your y on the left, move your constant, get your solution, and don't forget that for inequalities, you have to graph it. And it says it in the question too. It literally says graph the solution on a number line. So you'll know which ones you have to graph and which ones you don't. Doing good so far? 4 down. Let's take a look at number 5. Number 5 says solve for x. And number 5 is x plus 1/3 x equals 24. So our goal is to solve for x. So the first thing we have to do, just like the other one, turn all terms into fractions. Whenever you see a fraction, you want to create a common denominator. So I'm going to put this x over 1. I'm going to put this 24 over 1. And remember what I said before, this 1/3 x means that these are attached. So I'm just going to extend this out so that it's longer. Okay? So that you know that the x belongs on the top. After we turn all of our terms into a fraction, we're going to create a common denominator. And after we create a common denominator, we can cross out the denominator after we create it. So we've got 3, 1, and 1. So this bottom needs to be multiplied by 3, top and bottom, to maintain equivalence. And this one over here needs to be multiplied by 3, top and bottom, to maintain equivalence. So this is 3 times 1, which is 3. This is 3. And this is 1 times 3, which is 3. So I can cross all of that out. And we're going to solve the top. Now be careful when you set this, or when you rewrite this equation, because this is 3 times x, which is 3x. This is 1x. We didn't do anything with that one. This is 24 times 3, which is 72. And in this case, when we're solving the top, what we need to do is we're going to combine like terms. And that will give us 4x. And then divide. And divide both sides by 4 to get x alone. 4 goes into that 1, 3 left over, so that's 18. So our answer, x equals 18. Okay? So again, turn all terms into fractions. That's the pink. I'm going to make sure you understand that. As soon as you see a fraction, you should be turning all the terms into fractions. After you create a common denominator by multiplying top and bottom by the same number, you can cross out the denominator and solve the top. Don't forget that you have to do 3 times x and 24 times 3. Combine your like terms because they're on the same side equals, and divide. 5 is done. Number 6. We only have to go to 13, so that's a good thing. And this is as long as what your first part of your test is, so you can see how long it's taking. This is 4 times t minus 3 equals 8 times t plus 3. And in number 6's case, this is a set of 2 different distributive properties. So for my first step, what we're going to do is distribute on the left. So you get an orange. That's going to give you 4t minus 12. And then you're going to distribute on the right. See if this one works. Ooh, that's pretty. And that's going to give you 8t plus 24. So you have to distribute the left side and the right side. Don't forget there's an equals between them. Basically, I just wanted to show you that you needed two different distributive properties going on there. After you distribute, you have variables on both sides. You want to keep your t to the left. So that means I'm going to subtract 8t on both sides of equals. We always want to try and keep our variable on the left. So 4 minus 8 is negative 14. Bring everything else down. So 24. At this point, after you move your t to the left, you're going to move your constant. So you're going to add 12 to both sides. (24 plus 12 is 36). And then you're going to divide. And in this case, we're dividing by negative 4. So we're going to divide both sides by negative 4. That cancels. And t equals 36 divided by negative 4 is negative 9. And there's your solution. Okay, so again, when you have a distributive property on both sides of equals, you're going to just distribute them separately. And then get your variable on the left, move your constant to the right, and divide. Okay, number 7's a little long. It's long. 12 plus 9x minus 18 equals sign 9x plus 6 minus 3x. So number 7 is a case of combining like terms. So basically you've got like terms on the left side and like terms on the right side. So what we're going to do is we're going to combine like terms on the same side of equals. Ooh. Okay. So as you're doing this, on the left side, the like terms are going to be 12 plus negative 18, and we're going to add them. So the 9x is going to come down, but 12 plus negative 18 is negative 6. So that's what becomes of those like terms on this side. Okay. Then I've got an equal sign. On the other side of the equal sign, I've got like terms that are the x terms. So I've got 9x plus negative 3x. And when I combine those, I'm going to get 6x and bring down the plus 6 because that plus 6 is like the original. Nothing's changed. So now that you've combined like terms on the same side of equals, again, just showing you that these are the like terms that I got for negative 6, and these are the like terms that I got for positive 6x. Now we're just going to go ahead and do the same thing we've been doing, which is you want to, keep, that's the right word I want, keep x on the left. So if I'm keeping x on the left, that means I need to subtract 6x over. That cancels. 9x minus 6x is 3x. Bring down the minus 6, bring down the equals, and bring down the 6. We have to move the constant. So you're going to add 6 to both sides. And that gives you 3x equals 12. And then your last step is divide. So we're going to divide both sides by 3. And x equals 4. Okay, so in questions where they're a little bit longer in the beginning, it's probably because you have like some like terms that you need to combine. So you're combining these like terms. What's going to happen is these are going to collapse into smaller equations, and then you're just going to follow the same equation steps. Keep your variable on the left, move your constant to the right, and divide at the end. All right, we're more than halfway done. Moving on to number 8, we only have to go to 13. Looks like we're at the 20-minute mark, which means that for a quiz, More than halfway done at 20 minutes is pretty good. Number 8 says, solve for y and graph the solution on a number line. So this one is an inequality. So we have to solve the inequality and then graph it. Just want to make sure I'm copying it right. So I got negative 3y plus 15 is less than or equal to negative 27. So we have to solve for y and then we have to graph it. The good news is there's no like terms or anything here. So our first step for this one is going to be to move the constant. We're going to move the constant because our variable is already on the left. So I'm going to subtract 15 on both sides of the symbol. Be careful when you do this because when you're calculating, the symbol stays the same, of course. This is a negative and a negative, which is going to give us a bigger negative. So this looks like it's going to be negative 42. Okay. After you move the constant, then you're going to divide by a negative. So we're going to divide, but because we're dividing by a negative, this is huge. Boom, boom, boom. When you divide by a negative, when you have inequalities, do you remember what happens? When you divide by a negative, this symbol switches the opposite way. Okay? When you divide by a negative, you have to switch the symbol. So the 3's cancel with the negatives and you end up with y. This turns into a greater than or equal to. And negative over negative is positive, and this is 14. So this is my solution to the inequality. Y is greater than or equal to 14. But what we need to do is we have to graph it. When we go to graph this on the number line, 14 is our main guy. It's got an equal to symbol. And because there's an equal to symbol, I have to color in the circle. This is going to be a closed circle because of the equal to. And greater than indicates that we need to grow to the right. Greater thans are bigger numbers on the right-hand side of that number line. And number 8 is done. Let's go to number 9. Number 9, oh wow. Okay, so this one, again, a little lengthy. 7 times x minus 2 minus 4 times x plus 4 equals negative 20 plus x. So as we're doing this one, the first set of directions is you should see 2 sets of distributive property. So what we are going to do is we are going to distribute. I got to squeeze it in over here a little bit. So what we're going to do is we're going to distribute. And there's 2 different things to distribute. The first one we're going to distribute is the 7, and the 7 goes to the x and the negative 2. So when we distribute the first one, we are going to get 7 times x is 7x, and then 7 times negative 2 is negative 14. So that's the first set, is in orange. But this is the kicker, and this is the one where I need you to look really carefully, because the second set is not distributing just a 4. It is distributing a negative 4. So I have to distribute negative 4 to the x and a negative 4 to the 4. So negative 4 times x is negative 4x, and negative 4 times 4 is negative 16. So the key thing here is to don't forget that minus sign, because this is a negative 4, and that's what you're distributing. And then, of course, you're just going to bring the rest of the problem down. Now, there's like terms all over the place here. So we need to combine like terms. And that's on the same side of equals. So I'm going to combine the 7x and the minus 4x. I'm going to add those together, 7 and negative 4, and that gives me 3x. Okay. And then, let me see if I can get a pretty blue to work. We're going to have a negative 14 plus a negative 16. Those are also like terms. So a negative 14 plus a negative 16 is going to give us a negative 30. Okay? So the x is combined to a 3x. The negative 14 and negative 16 add up to negative 30. And now we can bring the rest of our equation down. So we've combined like terms, and now we need to get the x on the left. So I'm going to subtract my x over. Now remember, when we subtract x, it's really a 1x. So 3x minus x is 2x. Bring down your minus 30, bring down your equals, and bring down your negative 20. Okay, next step, move the constant. So we're going to add 30 to both sides of equals. Again, watch our signs here. We've got 2x equals, and negative 20 plus 30 is going to give us a positive 10. Then, of course, we have to divide. And you get 5. Boom. This was a big one. So again, distributing twice, making sure that you know that 7, you're distributing that 7 to both things in the first parenthesis. Negative 4 gets distributed to everything in the second set of parentheses. Make sure you're combining your like terms correctly to give you the right expression. And then make sure you move your x's to the left, move your constants to the right, and then divide at the end. Alrighty. So we're on question 10. Time to turn my paper over. Uh-oh, solve for y and graph. So we've got another inequality here. All right, just looking at this, making sure all is well. So we've got 16 minus 6y minus 4y is greater than 61 plus 5y. And even though this is an inequality, we're still going to start it off the same way. So what you want to do is you want to make sure that you combine like terms first. So I am going to combine those two, and a negative 6 and a negative 4 are going to combine to a negative 10y. And then, of course, I'm going to bring down everything else because there's nothing else that is a like term on either side. Okay. The second thing we need to do is we need to keep our variables on the left. So that means that I've got to take my 5y and subtract it over. So this is 16, and then negative 10 minus 5 is negative 15y is greater than 61. After we keep the y on the left, we need to move the constant. That means the 16 has to be subtracted that way. Uh-oh, I didn't leave myself a lot of space, did I? Negative 15y is greater than, and then 61 minus 16 is 45. Lastly, we have to divide. But we are dividing by a negative. So when you divide by a negative, you need to switch the symbol. So this bad boy is going to go in this direction. And when I divide both sides by negative 15, I wish I didn't have space to put it, but when I divide both sides by negative 15, I'm going to get y is less than, and 45 divided by negative 15 is going to give me negative 3. So this is my inequality. That's my solution. Now it's time for me to graph this. So I'm going to draw my number line. Negative 3 is the star of the show. There's no equal to here, which means I'm going to have an open circle. And this is a less than symbol. Less than goes with your left hand, and that means you're going to shade to the left. So we are looking for numbers smaller than negative 3. So that's to the left of negative 3. And there's your solution for number 10. All right, guys, hang in there. We're at the 30-minute mark, but we have 3 questions left. So if you're looking to see how much time it's going to take for you to complete this quiz, this is a pretty accurate description since we are just plugging away, doing the questions, spending a little bit of time explaining them. And of course, I'm writing the directions down on the side as well. So you have some really good notes to take your quiz. Don't get upset about this one coming. It looks aggressive, but it's not bad at all. So I'm going to teach you how to do this one. Or remind you, I should say, because I already taught you how. But we're real close to being done. Hang in there. All right, solve for x. Now, you see fractions all over the place, right? However, the very first thing that we do whenever we see a fraction is make all terms fractions, okay? So the first thing we're going to do is turn all terms into fractions. So let's see what that looks like here. I'm going to get my pink because that's customary. The first thing we need to know is that this x is attached to the 7/8, which means that I'm going to extend this fraction out, and this is going to be a 7x over 8. All right. I've got 1/4, which is a normal fraction, no problem. I got 3/4 x, which means I need to extend this one out with the x because it's next to the x. It's a multiplier, so these have to stay on the top. I've got 1/16 here, which is just a fraction. This is the problem. And this is what most people miss on this question, so pay attention. This is a denominator, 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 denominator. This is the one. This is the one that needs a 1. So pay close attention to that, because any term that does not have a denominator, you need to turn it into a fraction by putting it over 1. After we do that, then we're going to create a common denominator. And the cool thing about that is we've got 8, 4, 4, 16, and 1. So what resonates to me, I think, is the fact that 16 is the biggest number, and 1 and 4 and 8 all go into 16. They all have common factors. So that means that it'll be easier to make a common denominator. So I'm going to turn all of these into 16s. To turn 8 into a 16, I have to multiply by 2 top and bottom. To turn 4 into 16, I have to multiply by 4 top and bottom. Same with this one. This is a 4, so I have to multiply by 4 top and bottom. This already is a 16, so I leave this one be. I'm trying to get all 16s to happen, but this already is 16, so I don't have to do anything extra for this guy. But in order to turn a 1 into a 16, I got to multiply by 16 top and bottom. So let's double check. 8 times 2 is 16, 4 times 4 is 16, 4 times 4 is 16. I got a 16 here, and 1 times 16 is 16. So once we create a common denominator, we can cross it out and solve the top. So this is going shoom. Remember when we saw at the top that you still have to do your multiplying, okay? And keep your signs. So this is going to be 7 times 2x, which is 14x, minus 1 times 4, which is 4, plus 3 times 4 is 12x, equal sign. 1, nothing happened there, just 1. And this is x times 16, which is 16x. When you multiply a variable times a number, make sure the number goes in the front. There we go. So now we have a normal, little bit large, but a normal equation for us to solve. So at this stage of the game, we are looking to combine like terms. So let's get our pretty blue out. On the left, we've got 14x plus 12x. So 14x plus 12x is going to give us 26x. And we're going to bring that minus 4 down. And then these don't have any like terms, so I'm just going to bring these down. So remember that when we're solving, that you want to make sure that you keep the variable on the left. So I'm going to subtract 16x from both sides. 26 minus 16 is 10x. Bring down your minus 4. Bring down your equals and bring down your 1. Then we got to move our constant. So plus 4, 10x equals 5. Now pay really close attention here because this might be the spot where it messes you up. We need to divide, but what we are dividing by is super crucial. We need x by itself. So I'm not dividing by 5. I have to divide by 10. I got to get x by itself. So I'm going to divide both sides by 10. So when I do that, I get 5/10. That's not 2. That's not 2. 5/10 is 1/2 or 0.5. Use a calculator and double check. There's your answer. So that's 11. 11 was the challenge, but you're going to have another challenge on your quiz, so I wanted to prepare you for that. You've got all your steps right here. All we're doing is just kind of combining a lot of the stuff that we've been working on in little problems into one big bang. 2 more to go and we're done. Let's take a look at 12. Only got to go to 13. 30 plus 5 times x plus 3 equals -3 plus 5x plus 48. Okay, so the first thing you should notice is the parentheses. So we have some distributive property to do. So we can distribute that 5, and that's a positive 5. We're going to distribute that positive 5 to the x and the 3. So that's going to give us 5x plus 15. And we're going to bring that 30 down. On this side, there's nothing to distribute, so I'm just going to bring that down as well. Then we're going to combine like terms. So on the left, our like terms are 30 and 15. They're the like terms. So that's going to give me 5x plus 45. And on the right, our like terms are -3 and 48. And that's going to give us 5x plus 45. I want you to peek at this for a minute. These are identical. These are identical. But I got one more thing to show you. So stay with me, okay? And then we'll talk about it. So we want to keep our variable on the left. So what we're going to do is we're going to subtract 5x on both sides. And when we do, they both cancel. And you're left with 45 equals 45. And what this indicates, when your x's cancel out and you get values that match, your constants match, that is called infinite solutions. Now, what you can't do is you can't just leave it 45 equals 45. You have to indicate that it's infinite solutions, because the answer is you're solving for x. And this isn't solving for x. X isn't just 45. X can be any number at any time, because no matter what value we plug in for x, it will always work. And this is what you need. When the x's cancel out, when you keep your x on the left and your x's cancel out and your constants match, when they are equal to each other for real, that's when you have infinite solutions. Okay? Last one of the week. Last one. Preparing you for your quiz that you're going to take. 3x plus 4 times x plus 2 equals 11 plus 7x. Okay, so for number 13, I see parentheses here, so I'm going to distribute. And so when I distribute, I'm going to distribute a positive 4. And that gives me 4x plus 8. And then I'm going to bring everything else down, of course. Then what I'm going to do is I'm going to combine like terms. So I'm going to combine 3x plus 4x, and that's going to give me 7x. Bring down the plus 8. And then on this side, I've got 11 plus 7x. Okay, so we have variables on both sides. So what we're going to do is we are going to keep x on the left. So I'm going to subtract 7x on both sides. And when I do, this 7x cancels and this 7x cancels. And this says 8 equals 11. Huh. Does 8 equal 11? Can 8 ever equal 11? No way. So what we're going to do is put a line through it to indicate that that's not true. And when you have, get with me, when the x's cancel out and your constants don't match, when they're different, what you have is no solution. It's no solution because 8 can't equal 11. So you would literally write 8 cannot equal 11, because that's a true statement. And you would write no solution. And you know there's no solution because your x's canceled out and your constants are different. This and this are not the same. Whereas infinite solutions, your x's cancel out, but you get agreement. You get things that match or that are equal. That's infinite. No solution when they don't match. All right, guys, we are at the 45-minute mark, and that means that we are done. And what you need to do is take a picture of this and send it into Google Classroom for your notes grade for the week. And keep these notes because you are going to need them when you take your test. Good luck to you guys, and I will see you soon.